Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine a clinic's chatbot leaks thousands of patient records because a rule-based bot logged everything to a public blob container. That's the cost of a chatbot that doesn't think. In this video, we're going to build one that does. Last time you unlocked NLP text analytics and Q&A. Now it's time to give your AI a real voice and a safety net. By the end of this video, you'll be able to do 3 things. 1. Tell the difference between a dumb rule-based bot and conversational AI that actually understands language. 2. Build a fully functional appointment scheduling bot with Azure AI Language and Bot Framework Composer. No code required. 3. Secure and deploy that bot so it doesn't leak sensitive data. Let's start by demystifying the words themselves. Let's define the split. A traditional chatbot follows rigid rules and keyword triggers. No memory, no nuance. You type, "What's my balance?" and it falls apart. Conversational AI, on the other hand, uses natural language processing, machine learning, and memory to understand intent and hold context. When you ask Siri or Alexa, "What's the temperature?" they're not just scanning for a keyword. They're interpreting what you really mean. That's the fork in the road. This isn't just theory. Train Technologies tested a GPT 3.5-based personal assistant on office tasks. Productivity gains ranged from about 3.3% for straightforward work to 69% for complex tasks like drafting presentation outlines. Even a small gain per task adds up to hundreds of hours a year. That's why real conversational AI matters. It's a force multiplier, not just a chat widget. Before we click anything, you need the mental model. When a patient says, "I need to see Dr. Chen next Tuesday at 3 p.m., Azure AI Language, specifically Conversational Language Understanding, or CLU, pronounced CLU, decomposes that sentence into an intent, schedule appointment, and entities like doctor and date time. Then there's the none intent. If a user says, "Order pizza," and you haven't trained none with enough garbage examples, CLU will force-fit it into schedule appointment with medium confidence and your bot will book a pizza. That's the trap. Intents are what they want, entities fill in the slots, and none is the firewall. Quick check. What happens if you skip the none training data? Pause and answer. Got it? If you said the model might misclassify nonsense queries as a real intent, you're right. That's exactly the trap that can cause a bot to go off the rails. Now let's spin up the actual language brain. Open your terminal and log into Azure. We'll create a resource group and then provision an Azure AI Language resource. The kind parameter should be set to text analytics for language services like conversational language understanding. The free tier is often available for testing. Verify current pricing before deploying. After the resource spins up, we capture the endpoint and key into environment variables for the next steps. Copy these commands and you'll have the brain ready in 2 minutes. Now we load the brain's knowledge. The JSON we import defines 4 intents: schedule appointment, cancel appointment, check availability, and none. It also defines doctor and date time entities, plus a handful of annotated utterances. The critical bit is the none intent. It contains order pizza, blarg test, and I want to speak to a human. These are the real-world nonsense and frustration phrases your bot will actually hear, and without them, it would confidently book a pizza. We use the language authoring REST API to import the project in one shot. Training the model takes a few minutes, and it's asynchronous. You have to poll the operation location until it succeeds. Once training is complete, we deploy it to a staging slot so the prediction endpoint can serve the model. All these management actions follow the same REST URL pattern under Language, Authoring, Analyze Conversations Projects. Just swap the action and wait for the job. Let's pause and reinforce a critical concept. What happens if you forget to train the none intent with enough out-of-domain examples? The answer is, the model could misinterpret nonsense as a real intent, causing confusing or incorrect bot replies. Always feed it varied out-of-domain examples. The moment of truth. We fire a natural language utterance at the prediction endpoint. The response should show top intent as schedule appointment with a score above 0.8, plus the doctor and date-time entities populated. If it doesn't, the fix is simple. Add more annotated examples and retrain. You've now got a working language brain that rejects pizza orders and understands real appointment talk. Next up, we'll lock this bot down with managed identity and then step into Composer's Visual Designer. Hit subscribe so you don't miss it. Quick recall. What does the kind flag set to text analytics provision? It enables a suite of language AI services, including the conversational understanding component for intent and entity recognition. Download Bot Framework Composer from AK8MS Composer. After a quick install, launch it and sign in with your Azure account. Click New, Create from Template, and select Conversational Core. Name it Contoso Appointment Bot. The home screen gives you a visual canvas that replaces pages of C-Crow waterfall code with a flowchart you can explain to a non-engineer. Start with a conversation update trigger. It simply sends, "Welcome. How can I help you with appointments?" whenever a user joins. Then add an intent-recognized trigger for schedule, appointment. This fires only when CLU returns that top intent. Inside, use set property actions to store any doctor and date-time entities into dialog memory using the coalesce expression. Your canvas now shows the skeleton of an intelligent greeting and intent capture. Great, but what if the user didn't mention a doctor? That's slot filling. Add an if condition to check if dialog.doctor is null. In the true branch, insert a text prompt asking, "Which doctor would you like to see?" Then store the reply with set property. Do the same for dialog.datetime. After both are confirmed, send a summary like, "So you want to see Dr. Lee on Friday at 3 p.m. Follow it with a confirm prompt that understands yes or no. Now the bot holds a complete appointment request. Before we continue, let's lock in the division of labor. What does CLU give you, and what must the bot designer manage? The answer separates the language brain from the conversation skeleton. What happens when the user's request could be two things? A bot that picks one and hopes for the best is what leaked 4,500 records. Here's how to avoid it. If CLU returns scores within 0.15 of each other, like schedule appointment 0.52 and cancel appointment 0.48, you intercept the ambiguous pair and ask, "Did you want to schedule or cancel?" If you skip this check, the bot randomly cancels an appointment. Use an on unknown intent trigger as a safety net for everything else. Before ever touching Azure, test everything locally. Click the green Start Bot button. Composer builds your runtime, launches it, and opens a web chat panel. Type, "I need to see Dr. Lee next Friday at 3 p.m. The bot recognizes schedule appointment, fills the slots, and confirms. Try "What's the capital of France?" And it hits the none path, replying, "I'm still learning. Could you rephrase?" You just validated the entire conversation flow without a single cloud resource. But here's the part almost everyone gets wrong. A bot that works perfectly in local testing can still be a privacy disaster in production. Imagine a healthcare chatbot accidentally logging sensitive patient queries in a publicly accessible storage account without redaction. If your chatbot handles health data, every log entry is a potential breach vector. Design your logging system as if storage is public even when it isn't. To prevent a repeat of the clinic's breach, lock down your bot with 4 controls. Disable public blob access, scope a managed identity to the logs container only, redact personally identifiable information before logging, and set alerts for any anonymous access attempts. These steps turn a dangerous toy into a production-ready, compliant conversational AI. Before we publish, recall the 4 security controls we implemented. Here's a quick check. Which of those controls prevents anonymous access to your log storage? Now let's go live. Inside Composer, hit Publish and choose Publish your bot to Azure. Sign in, pick your subscription and resource group, and give the bot a name. Composer builds the runtime, deploys it to App Service, and registers a bot service, all automatically. Hop over to the Azure portal, open the bot resource, and test in web chat. The same confirmation you got locally now comes back from a real production endpoint, with 0 manual as web app deploy commands. Heads up, the old web app bot template that spun up a bot with a single click no longer exists. It was deprecated. The current, supported workflow is the one you just used. Composer, or if you really must stay in the portal, a manual pairing of an Azure bot registration and an app service. But let's be honest, that just recreates what Composer does in one click. So stick with the visual builder, and you'll always be on the modern path. Here's what you've actually built, end to end. The user talks to bot service, which hands off to the Composer runtime on app service. That runtime calls CLU to get intents and entities, then uses a managed identity to securely hit the backend appointment API. Redacted logs land in private blob storage, and Application Insights watches everything. No static keys, no public data, no guessing games. You can't fix what you can't see. Enable Application Insights on your app service, then run a Custo query that checks the average confidence of each intent. If you spot intents like schedule appointment hovering below 0.6, it means the model is guessing, and that's when patients end up frustrated. The same query also reveals how often the none intent triggers. If it's above 30% of total requests, your CLU project needs a heavier dose of out-of-domain training data. Time for a real talk. That PII redaction middleware isn't a nice-to-have. It's what stands between your bot and a headline. It strips out names, medical terms, and personal identifiers before any log entry touches storage. If you don't bake it in from day one, any engineer peeking at the logs, or any misconfigured access, becomes an instant HIPAA violation. You've already seen the 4,500 record example. Don't be the next case study. Let's close the loop. At the start, I promised you'd walk away knowing the difference between a dumb bot and conversational AI. You've seen how CLU turns a sentence into structured intent and entities, and how the none-intent stops nonsense. You've built a full appointment scheduling bot in Composer, visual designer, slot filling, the works. And you've locked it down with the same security patterns that would have prevented a 4,500 record leak. That's not a demo. That's a deployable skill. Before you leave, engrave these 3 pitfalls. First, undertraining the noon intent. Your bot will treat order pizza like a medical request. Second, leaving logs public, the exact trap that leaked 4,500 patient records. Third, skipping confidence score checks. Without a disambiguation rule, a near tie between schedule and cancel flips a coin on the user's behalf. Fix them now, and you'll never have to apologize later. You've built a bot that reads text. In the next video, we'll make it listen and speak. You'll add real-time voice interactions with Azure Speech, transcription, synthesis, and translation, so your bot can have a hands-free conversation with a doctor or a patient. See you in Part 9. Here's your 30-day move. Spin up a free Azure account, create a language resource with the CLI command we used, import the project definition .json, and test it with curl. Then download Bot Framework Composer, connect the recognizer, and publish. By the end of the week, you'll have a live bot you can show in an interview. While some AI 102 exam content references Lewis, real-world employers are asking for CLU and similar modern services. You've just future-proofed your skill set. If this helped, smash that like button and subscribe. We'll see you in the next one. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.